Hey guys, this is EG1011 Prac 2 for 2018. The Prac itself is in room number DD014-115. There is a computer in the room which you'll use to do your experiment, the login for which is EG1011, all in capitals, and the password is student with a capital S. Alright, so before you get to the room, you're going to need to collect a few things. You'll collect them from Mel at the front counter. So we'll need our Pasco motion sensor. We'll need a tape so you can measure your distances, and a caliper so you can get your correct sizes on our steel disc. The program we are using is this Pasco capstone. Come on. So this is us here. We'll be using this feature which will give us the values for pretty much position, velocity, acceleration with respect to time or vice versa. So we'll select our measurements for this one. We'll use position and time. We'll set up our graph with our, let's go position, respect to time. See how that looks? And we've got record down here. So when we're ready, we set up our motion sensor just like that. Our steel disc. Where are we? Record, and that should be us. Alright, so what we've just recorded is position with respect to time. We've also recorded acceleration and velocity as well, but they're not on our graph. Alright, so we stop it. We export our data. Export it to the desktop. You will need to make it a CSV file. CSV stands for comma separated variable, and it's a format that's used for raw data. Alright, Prac 2. Alright, so this is our Prac 2 data here. Open it up. Alright, so our data, we've got the date, we've got the time of the run, how long the run took, we've got the position, velocity and acceleration. Before we start working, we will have to save this file as an Excel file. CSV, it's very hard to save different formats, so we put it into an Excel workbook. Alright, so you guys have to plot this data. I'll just quickly have a go at it. So what I'm looking for now is when the actual experiment started. So we should have a 0 position somewhere. Alright, so 1.59 meters, that's when it's hit the end of the rig, so that's pretty much the end of our test run. And position, looks like about us there. Alright, so if we plot our graphs, that's us there. I generally zero the time. You can see on our time here we've got a bit of a gap, so I'll just zero that usually. Makes it much prettier. 12. We've got some funny ones in the acceleration by the looks of it. What's that one? Alright, so there's our plots. Alright, so we can now see our position is changing with respect to time. Our velocity looks pretty linear and is increasing with time. It's a bit hard to tell. It looks like our acceleration is pretty constant. We've got a few spikes here which will relate to the rig itself. There's a few dings and bits and pieces missing in the rig, so yeah, it doesn't surprise me we get funny accelerations, but it looks pretty constant, which is what we'd expect to see. Alright guys, so that's pretty much it for the prac. I've just done one run. You guys have got to do 30 runs. So there'll be 5 different constant distance, so 5 different slopes and 3 runs each. Also a constant slope with 5 different distances and 3 runs each. You're going to end up with a lot of data. And I would suggest you try and get it all onto one graph. So position will be one graph, acceleration will be one graph, and velocity will be one graph. I'd say will be the neatest way to do it, but I'm really not sure. We haven't used this Pasco motion sensor before, so surprise me. Other than that, that's about it, guys. Once you finish the prac, take everything back to Mel, front counter, for the next group. The prac itself, I believe, is due the end of October. I'm not sure the exact date. It might pay to check with Peter or Learns ACU. And submit it in the Dropbox in the hallway. Alright guys, that's about it for this prac. If you've got any dramas, give me a yell or Peter. Cheers. Thank you.